So here we've got everything underway with the construction of our oven. We're making the cob material, we're mixing the cob, we're making the cobs. Down over there at the cob making table, it's like a tree full of them and parrots at the moment, so the work's carrying on really well. So I'd like to take the opportunity to just explain a little bit about the design principles behind the oven. Now, this is our main material. It's cob. It's an ancient material of just sand and clay and straw. Commonly available everywhere. So it's the only material that I know of that you could make the complete oven out of. Like if someone came along today and said, oh, the university's got this new material they've invented. It's made from commonly available materials, it's economical, mostly comprised of things that you can just dig up out of the ground everywhere, or biomass, that's the straw, that's the word I was thinking of, the biomass. So what we've made is a material, and then not only that, but then for the outer layer, the insulating layer of the oven, we make it out of the same materials, just in a different ratio. So what we're looking at for this internal wall of the oven is very high thermal mass. Now the problem with something like this cob, once it's dry, it's very similar to a brick. So it's very heavy, holds a lot of heat, but it transmits the heat quite quickly, which, as it turns out here, is a good idea. So we make the cob with mostly sand and clay and only a small amount of straw for this layer where we want the heat going into and stored for later use for cooking our bread. Now this outer layer, we make that out of what we call light clay. It's just like a clay soup mixed in lightly with the straw, and we pack that over the oven like a huge blanket to keep it warm. That means all the heat from the fire is actually stored in the very dense cob, and then that's released once we take the fire out and block the door of the oven off. And that then gives back the heat to cook our bread, the beautiful conductive and heat, even heat, to cook bread or roasts or things like that. Of course, sometimes we use the oven just with the fire going, and we cook pizzas and roasts and things like that in this part of the oven. But see, straw is very light, so it's very low in thermal mass, but very high insulation, and that's what we're looking for here. Now, the design of the oven itself is the most intriguing thing. It's based on the principles, again, of sacred geometry. Now, if you took this line here, that's the level of the floor, that's the level of the height of the door, and then this is the height of the oven. Now, to have this oven work perfectly, the ratio of this line to this line is the same as this line to the whole line. Now, there's only one place on this line here where that occurs, and it is a ratio of 0.1618 forever. In other words, it doesn't exist, which is amazing. I wonder why that would be, that the place that actually makes the oven work perfectly is the one where it doesn't exist. So we don't really know, and there's much conjecture in the art world, because it's not only ovens that work with this ratio, it's everything that's attractive. And of course, not only attractive, it's what makes the oven work. If we have this ratio too high, we end up with dead spots in the oven and it doesn't heat up properly. If we have it too low, we're very inefficient, because the time that the hot air is in contact with the cob is far too short, and we have an inefficient oven. So that ratio, how did they develop it? Well, we don't really know, but here's something interesting. If you go, make the 5-pointed star. Now, if I did that perfectly, of course it makes a pentagon in the centre, but if I'd done that perfectly, every time these lines are dissected, they dissect at exactly this ratio. This is the ratio nature uses to build everything. The ratio, like if you remember Leonardo's Vitruvius Man, from here to here, the perfect ratios of a person complies with this. The length from my arm to my tip of my fingers is this ratio where the elbow. It's found everywhere in nature, and it works beautifully for pizza ovens. Now, another aspect of sacred geometry we use is in with this doorway. Now when you look front onto that doorway, it's what we call a cycloid arch. Now I've been at many of these oven buildings and at other talks I've given. I've never been able to find an architect who can actually draw a cycloid arch. I might find out now. David, can you draw a cycloid arch? A cycloid arch. It's the arch that's formed when you roll a circle along a flat plane. I've never found anyone who can tell me how to draw it geometrically. Well, it's the cycloid arch, I'll show you. No, David doesn't know. So how we do it, if you have a circle here and you start with this point on the circle and rotate the circle that way, if you can imagine, it starts coming up, only coming in slightly. As it gets towards the top, it levels out and then comes back down the other side. That's a cycloid arch. Now it's the strongest shape known to man. I think Christopher Wren used it. You'll recognise it from a lot of the bridges and things like that. Now that's how we did the oven doorway, for the archway for the door. And it's not the only place we use that shape, because when you have that shape and you turn it up the other way, and you can actually have, it's the only shape in the universe where every ball bearings placed anywhere on that dome will all reach the centre under the weight. Imagine it's tipped up the other way, under the weight of gravity, all reach the centre at the same time. So it's got a lot to do with how it controls the energy in our oven. So now coming down to looking down on our oven, we don't have it round. The round oven would be through around there. Now here again, it's not something we learn so much from science, although it complies with the laws of science and physics, as you can see. It's got to do with, this is how people have built ovens for thousands of years. And so we start off with a circle, and then you simply elongate it. Now you might recognise that a chicken's been making this shape for many, many years. And if you can get the big strong fellas, they can put an egg between their hands like that and they can't crush it. It's because we've got this same cycloid shape. So by doing it with that, and if you actually put the star inside here, we've got exactly the width of our door. So when you based, and this is based on traditional ovens, it just so happens that it also complies with what we've learned from sacred geometry. So that's the design principles of the oven. Let's get back to building it.